According to the interwebs, this IBM doesn't exist. And yet, here it is on my bench. When I saw the ad, I thought the seller made a mistake, but after having looked carefully at the pictures in the ad, I decided to grab it anyways. As far as I know, there were only 2 variants of the Model 50, aside from a few hard drive options. The 10 MHz 286 with wait states, and the 286 without wait states. Now check this out. This IBM claims to be a Model 50 486. I checked on Google, of course, but found nothing. So then I thought maybe it's a fake. So I took a closer look at the sticker. From what I can tell, this sticker was printed in the same machine that made the stickers on other Model 50s. It's actually not really a sticker. It's more like a thick plastic badge with print on it. So not so easy to fake and make it look this similar to the original badge. There were many different CPU upgrade boards back in the day, but I have never heard of a 286 to 486 upgrade. So whatever the heck this thing is, this should be interesting. A Model 50 was actually what I had back in the day, after my Commodore years. So if this IBM is for real, I will now get nostalgia and speed in the same machine. How awesome is this, after all these years? So let's explore it and find out what the heck this IBM is. I think someone swapped the diskette drive in this machine, because the eject button here doesn't match this much larger hole. So I think it was originally sold with one of these drives with a much larger eject button. I'll see if I can find a spare and we'll replace it. Unfortunately, this IBM came with a white switch. You know me, I'm tempted to replace it with a red switch. If this is some kind of custom machine, maybe I shouldn't. I just noticed this case is actually not identical to the Model 50 case. The Model 50 didn't have a grill on this side, like this case has. But the chassis is identical to the Model 50, because there's a case fan in here. This machine came without any cards, and by the looks of it, it never had any, because all 3 blanks are installed. Okay, moment of truth. What will we find inside here? Okay, that's interesting. We definitely have something going on here. Oh, the battery is still installed here. We'll remove it later. I don't think it has leaked. Well, that is definitely not a 286. There's this large PCB installed, where the CPU should be. So definitely not a standard Model 50, that is for sure. Now let's pull this damn thing out. Okay, we're in luck, it hasn't leaked. These Panasonics are great. I have yet to find one of these leaking. The hard drive and the controller are from a 50Z. The motherboard looks to be from a 50Z too, but we are going to check, of course. Unfortunately, we can't just turn the machine on, because we know from experience that these power supplies can sometimes have Rifa or Wima branded caps. They like to go bang and smell really badly. I'm gonna go for a complete disassembly. So I'll remove all the screws at the back here, except for the power supply and the motherboard. These machines are toolless. This machine also came with a 60 meg hard drive that can be removed by pushing on 2 tabs back here. These drives are known to have leaky caps, so we have fixed a few of these on the channel. And we'll fix this one too. These drives have the controller built into the drive on their main PCB. So they are just connected with another PCB to one of the MCA slots. And apparently this one is stuck, so there are no electronics on this PCB. It just connects the hard drive directly to one of the MCA slots. Same thing with the diskette drives. They are connected to this PCB here. This board doesn't have any electronics either. It just connects the drives directly to the main board. Maybe I should say sort of toolless, because the tool to disassemble these machines are actually included in every machine. But on this machine here, someone snatched it, because it's normally found attached down here. But luckily I have a few of these, so we'll just borrow one from another machine. Using this nifty tool, we can unlock all these tabs. This thing is really crusty. Unfortunately, these tabs don't age well, but I think there's a project to print new tabs. Oh, this one was really stuck. Let's hope it doesn't break. After releasing 9 of those tabs, we can now just take this machine apart. Like I mentioned, the fan is mounted at the back here, like on other Model 50s, whereas the Model 70 has the fan attached here. With all those tabs disconnected, we should now be able to remove the entire drive cage. So let's disconnect the battery and the speaker from the motherboard. Well, I'm not sure exactly how this works. This PCB looks detachable. Let's gently pull on this board and see what happens. Yeah, it came loose. Okay, so it was just stuck down into the CPU socket. There is some information on the board here, so we'll take a closer look in a minute. But first, let's finish the disassembly, because it's almost done already. Just a few more screws on the motherboard and one more screw at the front of the power supply. With all the screws out, we can now disconnect and remove the power supply. And in this machine, the power supply is made by AMTECH. Okay, and next I think we should be able to remove the motherboard. Well, I have removed all the screws on the I/O shield at the back, but the motherboard is still stuck. Okay, I had to bend it at the back here, and now I think it's free. Yep, here's our motherboard. Now that's a bit odd. The RAM stick is all bent. Never seen that before. The power supply is put together with security screws. And the usual disclaimer, of course. Please don't mess around inside power supplies. The caps inside may be charged with high voltages, even with the cord unplugged. Okay, let's pull that lid off. And see if this power supply has any nasty surprises inside. Well, it's been running hot, really hot. Just like the power supplies in the other 2 Model 50s we have restored. But the good news is that nothing is leaking or bulging, and there are no RIFA caps inside this power supply. So this should be safe to test. The caps on the hard drive, however, they are definitely leaking, just as expected. So we need to replace those caps before we can start this machine. So first we need to remove the rail. And then we need to remove these absolutely tiny T8 screws to remove the PCB on the hard drive. The drive is connected to the PCB with 2 tiny flat flex cables. One at the back here and one on the side of the board here. And as expected, the caps on this drive too are leaking. So even if we're not going to use this drive, we need to repair it anyways, because if those caps are left in this drive, they're going to destroy the PCB beyond repair. And I probably have a matching project for this drive too. So let's remove the rails underneath the drive. I think this drive might be for a Model 70, but I'm not sure. I'll check later. I actually have a Model 70 without a drive, so that would be a good thing. Before we can remove the PCB underneath, we need to disconnect the heads, the 0-track sensor and the stepper motor. By the way, this is a Mitsubishi drive, and it is of course an IBM PS2 special. So now we can flip that PCB. This drive only has 2 caps here, and they are not happy. They are leaking, but it doesn't look like they have damaged anything. All the surrounding components and the traces still look okay, but the cap tubes have started to corrode away at the solder. So perfect timing. They are ready to be replaced before they can create any more damage. Okay, I found a spare drive that I think might be the matching drive for this machine. This drive has been partially disassembled already. I have probably checked and ordered the caps for it. So let's just quickly check before the wash. Yeah, still original caps on this drive. So we'll replace these and then we'll test and see if this drive fits in this mystery machine. The lid has unfortunately been damaged. 3 plastic bits on this side are broken off, and this tab here is almost broken off completely too. But we are of course going to fix this, either in this video or perhaps in a follow-up video. I have not compared the part numbers, but this drive looks identical to drives we have found in other Model 50s. So I'm pretty sure this is the matching drive. We can't use the rework station to remove these caps because they are very close to the motor here and this plastic component here. And same thing with this cap here. So we're gonna have to use Chip Quick on this drive. I previously used Kemet brand rated for 124C, but I almost ran out. So today we're going to try out Chip Quick branded Chip Quick. This is Chip Quick SMD 4.5. And it has a very different melting point at 58C. So this should be interesting to try out. Let's get these wires out of the way so we don't damage them. I'll add some flux to all the pads. And then I'll add a blob of Chip Quick on each pad. Yeah, that is definitely melting much quicker than my old Chip Quick. But that's actually not the important thing with Chip Quick. The important thing is how long it stays molten. So if we heat up this side and then this side, yep, that cap came right off. Love this stuff. This guy here is a 10 microfarad 16 volt cap. So I'll just do the same thing. This guy here, that's a bit too much, but it doesn't matter. This stuff is really cheap. I've been using one piece for probably about 4 years. And this pack from Mauser, I got 9 pieces. So this is gonna last a decade. This guy here is a 1 microfarad 50 volt cap. So the way this stuff works is that it stays molten for much longer than regular solder. Okay, so this is the tricky one. I can barely reach that pad with the tip. So getting some Chip Quick on that pad is a bit difficult, but it worked. Okay, let's add some on this side too. So one big difference with the Chip Quick branded Chip Quick is that I get much bigger blobs. So that's not really a bad thing, but it could get a bit messy. So the way to do this is to melt one side and then move over to the other side and then just push the cap off. Yeah, as I said, this could be a bit messy. So now I've got Chip Quick on this chip too. This guy here too is a 1 microfarad 50 volt cap. Removing this stuff is easy with some flux and wick. So let's clean up that flux and inspect those pads. So the Model 50 came out in 1987 and replaced the IBM AT, and they were really successful. So they made about 500,000 of these just in the first year, and they remained popular for quite a while. I think they made 1 million in total. Okay, I replaced the other 2 caps off camera. So this drive should be ready to test. Okay, I greased all the usual spots. Let's check the mechanics. Yep, totally works. I'll recap the other drive off camera because I don't think we're going to use it in this machine. I just realized my mistake here. I should have checked the part numbers. This is a double density drive. So this drive is for another project. Well, it needed recapping anyways. So now it's ready for another machine. But I'm gonna have to find another drive. I'll recap it off camera since we have already done this one. Okay, I found a drive. As you can see, they are very similar, but the double density drive is marked 413CO4A and high density drive is marked 713A01A. The high density drive is also supposed to be marked with 1.44 on the eject button. But on most drives nowadays, that text is worn out. You can barely see the remains of it here. So that trick is not useful anymore to identify these drives. The PCB for the hard drive doesn't have any plastic parts nearby, so we can just use a rework station. This drive is in a much nicer condition than the 2 drives we have repaired in previous projects. I'm pretty sure you can use a double density drive in the Model 50, but then you would of course only be able to use 720K disks. I guess we could test if this machine actually works. So these two are 47 micro 16 volt caps. And the third cap up here is a 100 micro 6 volt cap. I don't see any damage to the board, but I can see some mild corrosion on these pads here. And on the solder on the caps. So they are definitely leaking. The other 2 drives we have repaired already had some corrosion on the pads on this chip here and on this chip here. The wick is slightly abrasive and there are some traces between the pads here. So if you push too hard with your tip, you will scrape the solder mask off these traces and you could potentially get a short underneath the cap. I checked, of course, and the solder mask on this board is completely undamaged. Okay, I did an inspection. It looks pretty much perfect. I have already washed this board, so it's ready to be reinstalled on the drive. Okay, let's have a look at the motherboard next. My guess was right. This is indeed a 50Z board. So the second revision of motherboard for the Model 50. The part numbers on the ROMs are for a 50Z too. I'm really surprised here. Why didn't they just use Model 70 board? It would have been a much easier upgrade. So I kind of wonder, maybe they had an overstock and just tried to get rid of these boards by installing a crazy upgrade. That is a possibility, I guess. The 286 socket has something sticky inside that didn't come off in the wash. Otherwise the board cleaned up really nicely. If you're a purist, you may want to look away for a minute. Some PS2s were sold with a big red switch, but for whatever reason some machines had this plain white switch. My machine back in the day had a red switch, so PS2 with a plain white switch sort of kills the nostalgia for me. It just looks all wrong. This is, by the way, a standard Arrow part. I'll put the original switch in the bag and leave it inside the machine in case someone wants to put it back to original in the future. Let's put the screws back in. No one will ever know. Okay, now that brings us to the mystery board. Now let's see what the heck this is. It has IBM part numbers, so it's not an aftermarket thing. It has a bunch of switches and 2 chips marked hypertech, made in Japan. On the other side, designed for IBM by Hypertech Research. Okay, cool. It has an empty socket for Mathco. And this chip here looks like a 486 SLC. Let me check those numbers. Yeah, sure enough, that is actually an SLC2, rated for 50 MHz. Wow, that is quite an improvement from a 10 MHz 286. And check out this crazy contraption here. It has a really sticky pad. Let's lift this up. See what's going on here. Okay, so it's a large piece of ceramic or plastic, and then it has tons of pins soldered to the side and to the board, and it's obviously made to fit in a 286 socket. So pretty wild card. It also has a 50 MHz crystal here and what looks to be memory chips, and 2 more of those on this side. Let me check what they are. Okay, so these are Fujitsu MB8298 and they are CMOS 256 kbit high-speed SRAM. I did a Google search for these hypertech chips here. I wasn't able to find a datasheet, but the search led me to a page on Ardent. Of course, where else? And apparently these boards are known as the Hypertech 50Z. So it definitely belongs in this machine. And that was all the information I could find online. So I can't say I'm much wiser. Why is this the only known machine on the interwebs? Well, I guess we should try it out and see if it works. Okay, I put everything back into the machine. Everything has been washed. So this machine looks pretty much as good as new now. I'll be an optimist and put the lid back on before the tests. As I suspected, that eject button matches this case perfectly. So this is very likely the matching drive for this machine. Well, I'm a bit biased because I had one of these back in the day, but I think these are great looking machines. Love that industrial IBM design, and with some details in red and blue, I think they look great. Now the moment of truth. Let's see if this machine actually works. Fingers crossed. Well, the fan spun up and I can hear the hard drive and it posts. We've got 1 meg of RAM and a bunch of errors because we have removed the battery. So let's run the reference disk and see if that drive works. The hard drive sounds really good. It's not making any noises. So if you're new to PS2 systems, the reference disk is used to access the BIOS settings. And it works. So that drive is good too. And we have the usual battery error. This is perfectly normal if you're replacing the battery. Automatic configuration is being run. Automatic configuration complete. So let's boot. See if that hard drive works. I had to import this machine. So let's see what language DOS is in. Okay, 1 meg of RAM and still one error. So we need to set time and date. Let's go to set features, time and date. I'll just go with a random date because I'm going to mess around some more with this machine. Save and exit. PC DOS something. So DOS seems to be in German. I have no idea what that means. But let's check what version of DOS we have. PC DOS 7. Revision 0. This looks to be a clean DOS installation. So unfortunately no fun games installed. But hey, we've got a working hard drive and it sounds really good. It's very nice and silent. Although the fan is quite noisy in these machines. So I'm going to replace it with a notcher fan. So the next thing we should try is check CPU. By the way, the cool thing about these PS2s is that they are extremely well built. Everything feels so solid. Even the diskette drive feels completely different from clones. Okay, let's run check CPU. And indeed, we've got an IBM 486 SLC or SLC2 running at 50 megahertz with a clock multiplier of 2. So it's running at bus clock speed 25 megahertz. That is quite a bloody upgrade for 10 megahertz 286. So how about cache? Holy smokes. We've got 16K of cache too. So this should be pretty crazy fast Model 50. Let's try speed sys. I'm trying to type Y, but I'm getting the wrong character. So apparently we have a QWERTZ keyboard installed here. Yep, we sure do. Okay, so we've got a 486 SX50, 1 meg of RAM and a 58 meg hard drive. We're getting a significantly faster score than a 386 DX40, but not quite as high as a DX250, but not too far off. So what do you do with a crazy fast Model 50 oddball? Well, I think we should try to make it even faster. I'll order some stuff and make a new video When it's done, I'll put a link on the screen shortly. If you're watching this fresh, hit the bell icon below and set it to all. Meanwhile, check out this video. I will end by saying thank you to my patrons. I appreciate your support. If you want to support me too, consider becoming a patron. Patrons get ad-free early access. If you like this video, let me know with a thumbs up and a comment. If you're a regular viewer, consider subscribing to this channel. Thank you for watching. I'll see you next week.